Hey, I have a second channel. Cube Compium DDX.
Hey everybody. So I'm sure you probably have at least a handful of these guys sitting around. These wall adapters that power various devices or accessories you may have. And one thing you may notice is you may remember, I don't know, 20 years back, 10, 15 years back, a lot of times the wall adapters that would power things like cordless phones or just any kind of like small device, you may remember how older wall adapters feel noticeably heavier than modern day wall adapters. Now both of these call themselves class 2 adapters, and I'm not sure if that's the accurate name for this guy right here, because this is actually a much newer wall adapter. And it's actually, what it does is it just simply supplies 5 volts to a cordless screwdriver to charge. This, not exactly sure what it went to, but I also have over here this USB power adapter. And another thing is, you may notice how modern wall adapters or USB adapters like this little USB power supply, for example, you may notice how they're much smaller but yet put out a good bit of current. So this little adapter here is rated for 5 volts 1 amp, so a good 5 watts. This is what this thing's rated for. But here you have this old class 2 transformer, would be the correct name for this guy. It's rated to put out 12 volt DC, 100 milliamps, but it's way heavier than this right here or this right here. So the key thing is, modern wall adapters, or at least most of them, are way more efficient than older ones. That's because modern adapters use a switch mode power supply in them. They have a small circuit board in them with a switch mode power supply or switching power supply. Switching power supplies are much more efficient than traditional transformers. So what's in this, and this is what makes it heavy, is it's simply a transformer. It steps on 120 volts AC, or if you're in a different part of the world, 240 volts AC, down to 5 volts, 12 volts, or what have you. And to get DC out of it, they have generally either a full wave, full bridge rectifier or full wave rectifier to convert the AC signal to DC, and a capacitor to try to smooth it out. But other than that, there's not too much in these, and I was going to try to tear it apart, but it's actually getting pretty late as it is. And I'm sure there's probably videos out there already of people tearing these things apart, but so I'll give you another example. So this here is a class 2 transformer, rated for 120 volts AC in, 12 volt DC out, just 500 milliamps. So yeah, and this thing, I should mention, is pretty heavy. One thing you'll notice about these is even when they sit plugged into the wall, but there's nothing plugged into them, you'll notice how they still getting considerably warm. And that's because they're not efficient at all. They're just a linear power supply. It's just a transformer steps down the high voltage AC to low voltage AC, and it's converted to DC. Now actually, I do have some wall transformers in here that are literally just that. They are literally just a transformer. All they do is they take AC in and they convert it to AC, and that's it. So this little wall adapter, class 2 transformer, it takes in 120 volts AC out of the wall, and it steps it down to 12 volts AC, and that's it. There's no diodes, probably no capacitor or anything like that, just a transformer. And literally, I mean, this thing has some sort of a plug that goes in here. Not even sure what this went to. I'd hate to tear it apart and then find out, oh, I needed it for something. So, but yeah, one of the reasons, of course, why they went with this is, of course, for efficiency. These things, when you have a bunch of these plugged in, the older style ones, like this big guy right here, when you have a bunch of these plugged in, you'd be amazed at how much power they can actually draw, even when there's nothing loading them. I mean, just when they're sitting with hardly any load on them, they can definitely pull some power, and it's not a whole lot at once. It's just like I mentioned, you could actually feel one of these that's been plugged in for a while, and with no load on it, and it'll actually feel warm on the exterior. In comparison, a modern day switching mode wall adapter or USB power adapter, you feel one of these when there's nothing connected to it. Generally, it's going to feel cool. Sometimes I might feel just a tad warm, but definitely would feel cooler to the touch with no load than a old-fashioned class 2 transformer wall adapter. So yeah, sometimes when you pick up one of these modern adapters, you think, oh, it's a piece of crap. It's so light. And now, to be honest, some of them are probably not built the best. I can definitely say that. But one of the big reasons why newer wall adapters that power small devices, one of the reasons why these newer things are generally much lighter than the ones of 20 years ago is simply because they use a more modern and efficient power supply in them. Instead of just a conventional transformer, they have a switching power supply. So a switching power supply takes in your 120 volts AC or your 240 volts AC, and I should mention a lot of these are actually full range. They can take either 120 or 240. And this one may be one as well, just trying to see here. Yep, 120 to 240 volts, 50 to 60 hertz, and of course it converts it to 5 volts. But the way it works is it takes in your AC, converts it to a high voltage DC, and then uses switching transistors to turn it back into a high frequency AC, which is you can use a smaller transformer on that. That's why computer power supplies tend to have transformers that are actually smaller than the transformers that you'll have in these chunky wall adapters. But yet, like for example, they can put out, you can pass a lot more power to them, and the biggest reason for that is simply because they're switching at a very high frequency. We're talking kilohertz, not just simply like 60 or 50 hertz. So that's the big reason is, of course, yeah, they so again, you get your mains voltage in, it's converted to a high voltage DC, it's switched back into a high frequency AC, stepped down to a little transformer, and then rectified into DC. And of course, there you have it. That's kind of in a nutshell how a switch mode supply works. A whole lot more efficient than traditional transformers. So anyways, maybe you learned a little something today. Hope you enjoyed this video. Thanks for watching.
Well everybody, that wraps it up for this video, and I hope you enjoyed it. If you did, please like the video. Also, don't forget to subscribe to Computer Channel, and be sure to tick that bell so you'll get notified when new videos are posted. Also, don't forget I have a whole lot of other interesting videos here on the channel to check out. And also, in addition, I have a second channel, CubeCompMTDX, where I have all sorts of other videos not exactly related to technology. Links to the channels are available at the end of this video. Again, I thank you for your support and thanks for watching this video.